My name is Kelly Paffel, Technical Manager for Invino Engineering, located in Tampa, Florida. We are a domestic international company focused on steam systems, engineering, design, optimization, and problem solving. Today I want to talk about steam system optimization. One of the items, how to eliminate steam and condensate leakage in the system. Steam system optimization. Steam and condensate leakage preventage. To improve the steam and condensate system, change must occur. No change, no improvements will occur. Change means to rise to a more desirable or more excellent quality or condition, make better. What we did in the steam and condensate system 5 years ago is not what we do today. Change must occur. And I'll be talking about the different changes that need to occur to prevent steam and condensate leakage. Steam and condensate leakage has a negative effect on steam systems and plant operation. The steam leakage loses both sensible and latent energy. Leakage erodes or wire draws. It increases the leakage size as time goes on. Permanent damage occurs to each component with leakage. As you can see here in the video, the leak here will grow as time goes on. Each leak will grow in size, causing more problems with the system and more energy loss. The other thing is that increases emissions. The more steam I leak to atmosphere and lose the sensible latent energy, more fuel I have to put in the boiler to produce the steam. So it increases emissions. So not only energy, we have to look at the emissions today. Steam leakage correction is one of the top 4 optimization items in the steam and condensate system. Correction improvement in the system. Most leaks in the system can be corrected without capital expenditure. So it really makes it a very good optimization item. Steam and condensate leakage has a negative impact on the steam system and plant operation. Number 1, reliability. Failures in valve, connections, flanges, causes production issues. Loss of pressure means loss of temperature in the system. So there's a lot of negative things that go on with the system if we have steam and condensate leakage. The other negative impact is safety. As you can see here, in this video here. Steam comes out. It's a hazard to the plant personnel. It's visibility. It's a high temperature, 212 degrees, the vapor's coming out. The hot condensate's also 212 degrees. OSHA tells us 140 degrees F or higher, we need to protect the plant from the hazards. So not only energy emissions, but also safety is a factor. The number 1 failure element that causes condensate and steam leakage is connections, specifically threaded connections. Anytime that we do a root cause analysis on leakage, threaded connections will become number 1 every time. The failure can be due to installation, improper thread, improper materials to seal the thread. Another one is corrosion. Corrosion can be CO2 corrosion, but it also can be oxygen corrosion. But it is the number 1 failure point. And people always ask, how do I get around these failure points? Well, threaded connections, we do welded connections. Flanges or tube connectors. Here's an example of what we can do in the system. So we have flange connections here, welded connections here, and tube connections here. People say, why you use tube connections? Because they are guaranteed not to leak. Flanges will not leak if they're properly installed. And of course, welded connections, if the weld is done by a certified welder, we have no leak problem. So the thing is that today we want to stay totally away from threaded connections and use weld, flange, or tube connectors. Steam valve failures, internal leakage and external leakage. Two major points. We'll talk about the internal leakage. When you specify valves for steam, then we need to specify the leak rate inside the valve here. The second is the packing here. So the second largest failure point in a steam and condensate system is standard valves. And people say, I use globe or gate valves. The last great revolution we had in a gate valve was 1941. So why not use newer technology in steam applications? And those items are either using a ball valve or a butterfly valve. So we typically use a ball valve up to 2 inches, normal installation. We have used ball valves up to 8-inch, ball valves up to 800 psi. When we get into the larger sizes, we use the high performance or triple offset butterfly valves. The thing is that they've eliminated the standard packing issues that we have with the gate and the globe valve. The other side of it is the internal leak rate per FCI or API standards is extremely low. Ball valves can be class 6 shutoff, which is the highest shutoff, and the butterfly can do the same thing. So here in a typical installation, here you can see we use ball valves. And these were installed 16 years ago, and they are still a tight shutoff today. So performance is pretty outstanding. The thing is that flanges and flange failures are due to not using the correct torque on the flange bolts and pipe movement that are not axial movement. So when you put a flange in, you need to know the torque spec, the torque pattern. The other thing is if you have other movements besides axial movement, then put in guides on the piping system to eliminate anything but axial movement. Of course, water hammer is another reason that causes steam and condensate leakage in the system. The other thing is the final probably element that we have caused steam and condensate is corrosion. Proper chemical program at the boiler plant using some chemical to counter the CO2 corrosion. The other thing is we want to, in condensate systems, use stainless steel for materials. And most people will use Schedule 80 pipe or Schedule 80 fittings and other components. The thing is, 2 types of corrosion we get is CO2 corrosion and oxygen corrosion. So do not blame everything on CO2 corrosion. It could be possibly oxygen corrosion. One of the things that it needs to do to protect the system from corrosion is checking the deaerator for proper operation. The proper operation of a deaerator is operating at 7 parts per billion or less dissolved oxygen without any oxygen scavenger being added to the deaerator for 48 hours, and that's per the ASME standard testing. So the thing is that adjusting this plume here can be done aggressively or not aggressively. That doesn't help. We want to do the testing right here at least twice a year on the deaerator, and the steam system also have testing done. Part of your system, root cause analysis, has to be part of the program. We have to understand failure and make changes. Design, selection of components so we do not have failures. Installations. Things have to change that we do not have to have leakage today. A normal steam plant should have no more than 3 steam leaks, condensate leaks per year. Do not accept leakage as normal. It is abnormal. This kind of concludes my presentation today. And the thing is we're here to help you out. Here's our contact information down below, our website. Please contact us if we can help you. We're here to help you not have issues with the steam operation. Thank you. Have a great day.